Salutare! A venit vremea să vorbesc din nou de un proiect foarte fain în care am fost implicat, cred că unul dintre cele mai mișto proiecte în care am și stat pe șantier o droaie de zile. Este vorba de clădirea de birouri din Oradea, făcută pe structură din CLT, pe care, surpriză, într-un final am reușit să o și certificăm în standardul de Low Energy House, în conformitate cu cerințele de casă pasivă, adică a fost gândită, proiectată în întreaga exigență de casă pasivă, dar am certificat într-o treaptă mai inferioară care se numește Low Energy. Și asta am reușit să facem pentru că întregile echipe implicate au fost super motivate și super atente. A fost un proiect greu, a fost un proiect complex, a fost un proiect interesant, am mai făcut câteva materiale video pe care vi le las, dar acum vreau să vă arăt surpriză un prim material video pe care l-am făcut în limba engleză despre acest proiect, pentru că am fost invitat în Statele Unite ale Americii la o conferință online despre casele pasive, despre construcțiile pasive, Passive House Accelerator, în care sunt un grup de oameni pasionați, dedicați și motivați să vorbească despre construcții în standard de casă pasivă din America și din întreaga lume. Și am prezentat acest proiect într-o noapte de miercuri la ora 3 dimineața, eram destul de copt de somn. Materialul video integral vi las link în descrierea acestui material, în descrierea materialului video de la mine. Doar că reparcurând înregistrarea cu ei, pentru că a fost via Zoom, am mers un pic sacadat, așa că repostez video-ul făcut alături de ei și pentru ei în cadrul acelei conferințe. Și dacă vreți să vedeți restul de întrebări și discuții pe temă și pe proiect pe care le-am purtat cu ei în acest grup, puteți să vedeți în continuare puteți să vedeți materialul video făcut de ei, postat pe Passive House Accelerator pe canalul lor de YouTube. Vi las link în descriere. Atenție, merge un pic sacadat și vă trebuie puțin răbdare, dar a fost foarte, foarte mișto și le mulțumesc de invitație. Bine, vorba lungă, sărăcia omului. Urmează mai multe materiale video în curând pe tema acestui proiect care a fost foarte fain și care este gata și de un an de zile este funcțional. Așa că încărcați-vă subtitrarea sau language pack-ul și vă invit să urmăriți în continuare acest material video. E făcut în engleză, n-am mai exersat de foarte mult timp engleza, mai seamănă așa un pic a Mother Russia, dar no, it's funny, e funny. Spor la vizionat, sper să vă placă acest material video și în curând mai urmează de acolo destul de mult content pentru că avem o arhivă foarte mare. Clădirea este gata, am făcut și un tur de clădire și mai sunt multe de vorbit, dar nu vreau să vă le vorbesc acum, vreau să vă le las pe data viitoare. Spor la vizionat! Hello all! I want to share with you the story of an amazing project, an amazing building that we were involved in. I'm Marius Șoflete, I'm a structural engineer and I design, I build, I teach and I preach sustainable method construction in Romania as a structural engineer, carpenter, passive house designer, trainer, affiliated to the National Order of the Architects in Romania and online content creator on my YouTube channel. Along with my team from Creative Engineering Office that I founded in 2013, we had designed the structure, we had made the technical details, the energy efficiency design and on-site technical assistance for the Creatopy's new headquarters office building commissioned by Gabriel Ciordaș, the CEO and founder of Smartware and Creatopy, and he's developing a lot of IT products. This entire project was a challenge because it had two main goals. The first goal was to be able to do this building as fast as possible, and this is the reason why the structural system chosen for this building was CLT, that you can see also here on the worksite, and also to achieve a maximum comfort for the future occupants, because this entire building was designed for new employees as a new office headquarters for the ongoing Creatopy team that will have soon 250 new members. The main goal of this project was to have a better comfort because they were already occupying all the buildings that could be rented in Oradea, the place where we've built this, where we've designed and built this new office building. And the main problem that they had in all these buildings was the comfort problems, because none of the buildings could give them the necessary conditions to be able to work with your mind as an IT software developer when you stay a lot of time in the building that has to comply with all your needs. The project started in 2018 when we had the first discussion about the project, and in 3 months we had the first architectural design. The architecture team was from Oradea, Vertical Studio, made from architect Madalina Mihailceanu, Chiș-Bulea and Florin Nan. They had their first proposal after 3 months, then when we started the project, and after 4 months finally we had the final proposal that was chosen by the owner, by Gabriel Ciordaș. But the challenge was to design it in less than a year. And this building that you're seeing now was assembled in only 44 days by the General Pro Construct team from Cluj-Napoca. They are one of the best teams from my point of view, carpenter teams from Romania. And I wanted to share with you another worksite that they are working now, because they are working with a lot of precision and with a high attention to all details, and making a building that complicated requires a lot of attention. Now I'm filming from another worksite from Cluj-Napoca, and I want to share with you this message as a pre-recorded video so that you can enjoy and feel the vibe of the worksite that we had among those 44 days. Because the ex-Smartware, new called Create a P building, was made out from 820 CLT panels, 890 cubic meters of CLT cross-laminated timber. We've chosen this structural system because of its very, very fast assembly time and period, because we had to design and build this building in less than 1 year. Why that? Because they really needed all the people to stay together and to work together in the same building so that they will be much more focused on their exponential growth. So back to our building. We had 25 trucks that brought the material from Austria. The entire building was prefabricated in the factory in 4 days. We managed to design it in 21 days as design all the structural parts, because it was a really challenge for us as engineers. We had to stay a lot with the architectural team and had to work shoulder by shoulder with them, due to the fact that ordering the entire structure, we needed to integrate all the technical details. We needed to have on each piece exactly its dimensions, length, width, thickness, all the chamfers, cuttings, trimmings to all the edges that needed to be joined together, all the quality of the lamellas, because the entire structure remained visible. Actually, it's the biggest structure of the Eastern Europe that is entirely visible. We've chosen to let the entire structure visible at the interior due to the speed that the finishing could be made by remaining the entire structure visible. We've made the first meeting with Gabriel at the end of 2018. We had the first design approved in March 2019, and then in May 2019 the worksite had started. Also, the assembly of the structure started in August 2018. So we had a very short period of time from designing the building to confirm it to the production, and also we had to make some decisions because we didn't have all the information at that point we've needed to be able to launch the production. As you know, I don't know if you know, but when working with German people and German factories that work like car factories, you need to confirm all the details, and you must have all the information of the structure to be able to pre-order and order and have the entire structure in the required time. Nevertheless, we also had to think how we will assemble it on the work site. We had to make different kind of scenarios, where to put the crane, how many times should we move the crane, so that we wouldn't spend any hour without knowing what to do. And to ease the entire assembly process, we also made some assembly manuals that we've distributed to all the craftsmen, so that each craftsman from the team did know exactly what he has to do, what kind of piece should he assemble, in what order, after what piece, and with whom he should work. Also, to be sure that everything is moving very fast, from the design office we went to the work site and we assisted the assembly team. And one of the interesting part that we've managed to make is to design integrated details, so that on single detail everybody knows what has to do. I'm giving for you this example of a foundation detail where we have the concrete slab that is staying on a foam glass gravel. The foam glass gravel is made entirely from recycled glass. It's an insulating material that also can be used as a structural material. It's a material with more multiple functions because it has a thermal coefficient very good. It also has mechanical strength, and in a thicker layer it also works as a waterproofing layer. Therefore, we've used about 2,000 cubic meters of recycled foam glass gravel that was made nearby of the worksite in a factory in Hungary. And then we've made this concrete slab. We've chosen the concrete slab because also we needed to move very, very fast with the foundations. The entire building goes on 4 levels. The architectural team chose to make just a ground level office building. Also, it was one of the requirements of the owner, so that actually the entire team could be united, because when you have a very tall building and vertical building, usually the teams are being segregated. They are not communicating with each other. So the design team chose to have this design of going over the hills with the entire building, so that everybody should meet each other and to make a connection between them. One of the concerns of the IT industry is that people usually are disconnected and they do not bond to each other due to the fact that they have to work alone in front of a computer. This was another requirement. So moving forward, on this concrete slab, we've put the sole plate that was made from hardwood, treated hardwood. Then we've mounted the CLT structure, and due to the fact that at that point we didn't know exactly, because we had to go very fast forward in front with the design stage to be able to confirm all the panels, we didn't really know how the earth fillings will be made around the building. So we had to take some extra protection measures. Therefore, we've made this cement board plying, but instead of putting the cement board ply directly on the wood, we've chosen to put some cement board strips so that we create there a ventilated channel if sometimes some humidity will go there to be able to ventilate it. Then on this layer we've mounted 2 layers of bituminous waterproofing. After this we've made the thermal insulation of the foundation connection with extruded polystyrene, because it's the most accessible material to be used, that it's not interacting with the water. And then we've made an extra waterproofing layer made from rubber, Firestone rubber, so that the water will not go inside all the joints created within the insulation material. Because, for example, if you are going to the ski and you have very, very big shoes, and then you have a small hole, then the water goes there, then you will feel cold and you will lose heat there. Then, when we estimated that the earth fillings will be done, we went on the facade with 20 centimeters of rock wool, rigid mineral wool insulation. And after this, we've designed and it was mounted a wooden ventilated facade made also from treated wood. On this detail, what was very important is that we've discussed with each contractor. You can see here contractors like Bejona. He was the contractor that was making the entire concrete workings, and he was the general entrepreneur. We had the general pro-construct, the guys who were mounting the CLT structure and made the wooden facade. We had the guys from Contil, which were making the waterproofing and so on. And they needed to be synchronized between each other in order to be very clear for everybody who has what to do, when, and with who has to work. Therefore, on these details, supplementary, we've discussed with each contractor, and we've made a very precise scheduling of the works to do. Nevertheless, when the details become very complicated, we've continued to make some video assembly guides for the entire team, so that they have clarity in what do they have to do. Because each second mattered, each hour mattered on this work site in order to be able to have it done very fast. So another interesting and challenging detail was the green roof and the attic of the roof, because we had green roof with all the layers. Also, we had 20 centimeters of mineral wool insulation, aluminum vapor barrier that was mounted on the terrace, and after this, waterproofing made from also Firestone rubber band, which is one of the most durable waterproofing that we had in Access. Also, it was a system that could be mounted entirely in cold, with cold gluing, without flame. The problem here and this attic, it was the vapor diffusion, because on the roof we didn't had any vapor diffusion due to the highly SD value of the vapor barrier, but the walls were letting the vapors go out. So we had this problem of connecting a very sealed system with a very open system. Therefore, this node here, we had to design it and to think it and to use another vapor barrier with other properties, so that we'll be able to make a controlled diffusion there. Even though from the beginning this house wasn't required from the owner to be a passive house, still we've designed and think and construct all the details of this project under the passive house principles. Also, we've made the entire passive house planning package calculations to be able to determine the heat demand and the energy demand, which I will speak about it very soon. But we've designed all these details without thermal bridges. So we had the thermal bridge free design because this also has an impact in durability. No? So going back to our passive house is the question, how did we manage to certify this building as a low energy building? Well, I said to you that this wasn't required from the start to be a passive house. Still, the main criteria was to have a comfortable building. Therefore, one of the key principles of the passive house design is to achieve the maximum comfort that the building can give to us. No? Therefore, we've implemented all these principles within the passive house. And then the final test came out. So we had to make the blower door test because we wanted to make this test not specifically for certification, but to verify the entire building process. We had some problems with the windows. The windows are made from aluminum, and they had integrated within this very thin frame a very highly performant thermal module made from aerogel. It's a material used by NASA to their space costumes. So we've required this highly performant window frames. The frames are triple glazed because we are in cold climate. We do have some requirements for thermal properties of the entire building envelope. I won't speak about them now, but I am posting them on the screen now because there are a lot of numbers. As I am an engineer and I do like numbers, charts and diagrams, but if we will start to discuss all about these numbers, we won't gonna finish this in required time. So we have these requirements for the buildings, also made by the law, but the main problem is that we are in a very cold climate. So if we are in a cold climate, we do need a lot of energy to heat the buildings by the winter. The problem with Romania was that the first building energy standards were imposed 15 years ago. Since then, we didn't have any requirements of having an energy efficient building due to the fact that Romania has natural gas resources and it has one of the lowest gas prices in Romania. So these kind of investments that we have to do to achieve more energy efficient building were not really appealing to the investors or to the builders or to the owners. Also due to the fact that in Romania the average income is way below the average income of the European Union. Therefore, everybody was thinking to build construction that could be done with the money that they had then. Nobody was thinking until 15 years ago how to make economies in energy in the time, or that we will achieve the point where we should use only regenerable resources. At this point, at the Creative Office building, no renewable energy production systems were mounted, but still it's thought to be put in the next step. So how did we manage to do this as a passive house building? I was telling to you that we've made all the simulation and all the design was made as a passive house building according to the PHPP, Passive House Planning Package, and we've managed to achieve an heating energy demand of 27 kilowatts hour per square meter per year. The entire building has 2,400 square meters of usable space, but still the treated floor area, as is it mentioned in Passive House Planning Protocol, it's considered 1,700. So we've managed to achieve this consumption step of 27 kilowatts hour per square meter per year, and also a cooling demand of 18 kilowatts hour per square meter per year. The challenge was with the primary energy due to the server room, which the server room and all the servers needed for this entire office building to function were requiring 2 times more than the entire energy of the building. Still, by making this energy efficiency design, by having very good materials, by having a very good quality in building, because all the contractors involved, the guys from the General Pro who mounted the structure, the general entrepreneur from Bejona, the team that made the waterproofing and so on, everybody had a lot of attention to the details. Therefore, while going on the work site, we've seen that the things are going good. So when we made the blower door test, the results were amazing, because we weren't expecting a 0.28 changes per hour as a result. Therefore, having also this result, after finishing the building, we've decided that we could make the certification in the low energy building standard, which low energy building, it's the same, has the same principles and the same criteria as the passive house standard. It's it's made by the Passive House standard. The work site is starting. I'll let the boys do their job, so let's have the conclusion in another part of the work site. So here's Alin. He's the team leader of the carpenter team that mounted the CLT structure. He's on the work site now mounting another structure. Actually, he's an electrical engineer who went to United States to America as a carpenter, working with work and travel. So from an electrical engineer, he became one of the best carpenters and CLT assembly leader in Romania, because he has a lot of experience. He works with a lot of precision, and sometimes he's giving a painful attention to the details.
Yeah, well,
we have to. Just to manage that, the entire building had around 160 linear meters of assembly, continuous assembly, and the final tolerance of the building was 16 millimeters. With that kind of precision are these guys working. So it's unimaginable how precise is working with CLT, and how nice and good is working with CLT. When you see this, when you see a structure like this, it's very hard for you to think that people are still putting brick after brick with some mortar between them. How was the entire experience for you? The entire building for Smartware. Huh? The project was called, at the beginning the project was called Smartware. Now they've rebranded, it's called Create-AP.
It was a great experience, probably a great life experience. You know, we were there assembling for 7 weeks, you know, working with 10, 12 people, and it was amazing. It was, you know, we all gained a lot of experience, and we learned a lot, and the whole team involved. I mean, structural engineers, project managers, they were all amazing people, and it was quite nice to work there. I can say it was a real pleasure.
Yes,
you know?
Even though we are not allowed to say this on the camera, we were working, actually they were working because I was just assisting them. They were working like crazy people, about 12, 14 hours per day.
Well,
12,
yeah,
but sometimes there were more, considering also the hours before the work site began to prepare the work site. But everybody was working there like crazy people all day long, because it was a challenge to finish it as fast as possible. This was one of the main goals of the project. But still, the entire team was working with pleasure, because they really liked to do what they were doing. And you can see now some footage from the work site. When you see these people who are working all day long, but still on their faces you can see happiness, because this is working with wood.
Yeah, that's right.
Good. Thank you, man. Thank you for the experience. See ya.
See you guys.
In less than 300 days, we've managed to design, build, and make this entire building usable for the new 250 employees of the ongoing Create-AP team. And their team is still growing, because now we are designing for them another 2 buildings for 1,000 new people that will come into their teams. Thank you for your patience to watch this video. I was Marius Șofete. I'm a structural engineer. I'm working in Romania, having my office, Creative Engineering, an office where we design and usually assist in building all kind of new and innovative buildings, where me and my partners, Caterina and Octav, we are also staying on the work site, enduring this kind of noises, so that we are able to design and to further teach other teams and other people how to build better in Romania. As sustainability is not an option, it's a need that we have to implement in all our projects that we are doing now. You can follow me also on Instagram. You can follow me on my YouTube channel, because I also making videos for construction. They are made in Romanian because they are made for the local building industry, but I have more than 250 video materials made in and for construction methods. Thank you again. See you at the next conference.